So now we want to discuss the concept of vertical asymptotes. So here we have a theorem. If f of x is equal to n of x over d of x, then if we plug in x equals c into this function, so then we have f of c is equal to n of c all over d of c. And if d of c is equal to 0 and n of c is non-zero, then the line x equals c, so this line here, is a vertical asymptote of the graph of f. So in other words, if we have a value x equals c that makes the function f of x have a denominator that is equal to 0 and the numerator non-zero, then x equals c is considered as a vertical asymptote, or x equals c is a vertical asymptote of f. Okay? And take note that only the denominator here has to be 0, because if the numerator is 0, then we have an indeterminate form, and in this case we only want the denominator to be 0. So from this theorem, we can also take note of certain statements that can help us determine if f of x has a vertical asymptote at x equals c or not. Okay, so we have here first the limit of f of x as x approaches c from the left is equal to infinity or negative infinity. And second, the limit of f of x as x approaches c from the left is equal to infinity or negative infinity. So in other words, if f of x either increases or decreases without bound as x approaches c from the left or from the right, then c is a vertical asymptote of the graph of f. Okay? So for us to understand this a bit more, let's try to look at an illustration. So here, let f of x be equal to x squared minus 4 all over x squared minus x minus 6. So we want to describe the behavior of the function near x equals negative 2 and x equals 3. And we have here a question. Does f have a vertical asymptote at these values? Okay, so let's start with x equals negative 2. So here we are asked to describe the behavior of the function near x equals negative 2. So it means that we need to determine the behavior of the function as x approaches negative 2 from the left and as x approaches negative 2 from the right. So in other words, we need to determine the limit of f of x as x approaches negative 2 from the left and the limit of f of x as x approaches negative 2 from the right. Okay? So let's start with the negative 2 from the left. So this is equal to the limit of x squared minus 4 all over x squared minus x minus 6 as x approaches negative 2 from the left. So note that by direct substitution, this will give us 0 over 0, which is an indeterminate form, which means that we need to factor out the numerator and the denominator and cancel or divide out like terms. So we can express this as equal to the limit of x plus 2 times x minus 2 all over x plus 2 times x minus 3. Okay? As x approaches negative 2 from the left. So with this, we can cancel out x plus 2. And then we're left with the limit of x minus 2 all over x minus 3 as x approaches negative 2 from the left. So then now by direct substitution, we get negative 2 minus 2 all over negative 2 minus 3, which gives us 4 over 5. Okay. And then, for the limit of f of x as x approaches negative 2 from the right, so this is equal to the limit of x minus 2 all over x minus 3 as x approaches negative 2 from the right. So same as the one here. Then by direct substitution, this is also 4/5. Okay, so this means that since the one-sided limits are the same, then the limit of f of x as x approaches negative 2 is equal to 4 over 5 or 4/5. Okay, so with respect to the behavior of the function, as x approaches negative 2 from the left and from the right, they both approach 4/5. Okay, so they both, so from the left and from the right of f of x, they both approach 4/5. And does f have a vertical asymptote at x equals negative 2? No, because our denominator is not 0. Right? Okay, so let's just write that down. The vertical line x equals negative 2 is not a vertical asymptote of f. Okay, so that's for x equals negative 2. So next, we need to, again, describe the behavior of the function near x equals 3. X equals 3. So similar to what we did for x equals negative 2, we need to determine the limit of f of x as it approaches 3 from the left and from the right. Alright, so for the limit of f of x as x approaches 3 from the left, this is equal to the limit of x minus 2 all over x minus 3 as x approaches 3 from the left. So this comes from here. Okay, so now note that the numerator will be a non-zero value, but the denominator will be 0, or it approaches 0 through negative values. Since we have x approaching 3 from the left, we can think of a value that is less than 3. So let's say 2.9. And if we plug 2.9 into, or if we determine 2.9 minus 3, we will get a negative value. So this means that the numerator is 1, is a non-zero value, and the denominator is approaching 0 through negative values. So this is now equal to negative infinity. Alright, so as x approaches 3 from the left, the numerator approaches 1 and the denominator is negative and approaches 0. So the fraction is negative and decreases without bound, and so it's negative infinity. For the limit of f of x as x approaches 3 from the right, this is equal to the limit of x minus 2 all over x minus 3 as x approaches 3 from the right. So similar to the limit of f of x as x approaches 3 from the left, here the numerator is non-zero, it's actually 1, and the denominator approaches 0 but now through positive values, since x is coming from the right of 3. So this is now equal to positive infinity. Okay? And by the definition of vertical asymptotes, so here the numerator is positive, or the numerator is non-zero, but the denominator is 0. So this means that 3, or x equals 3, is a vertical asymptote of f. Okay? So let's just summarize everything first. So with regards to the behavior of the function near x equals 3, so the limit of f of x as x approaches 3 does not exist. And that is because the one-sided limits are not equal to one another. So you have negative infinity and positive infinity. And with regards to the vertical asymptote, so the vertical asymptote, or the vertical line, x equals 3, is a vertical asymptote of f. Okay? Because it also satisfies one of the properties here. Since the limit of f of x as x approaches c from the right and from the left are equal to either positive infinity or negative infinity. And with regards to the behavior of the function, so as x approaches 3 from the left, it would approach negative infinity, while the limit of f of x from the right of 3 will approach positive infinity. Thus, the limit f of x as x approaches 3 does not exist. And this is now our final answer here.